All right, so this is actually section 3.10, the Hinge theorem. So normally we would do some investigating, but obviously that's not going to happen. So we're just going to talk about what the Hinge theorem is. So if we know that VW and RS are congruent, as we can tell by their markings, and we know that VX and RT are congruent, again, we can tell by the markings, and if we also know that angle V is greater than angle R, which they just came up with some examples so you could actually see some numbers, but 88 is bigger than 35, then that means that WX here has to be greater than, in length, we're talking ST. And you can see visually that would be true. But because a greater angle, it's going to make the side obviously a greater length, and it works in reverse as well. If BC and EF are congruent, and AC and DF are congruent, and then we say, hey, the third sides are longer, or one's longer than the other, then we could say that the measure of angle C down here is greater than the measure of angle F, because that longer side is going to stretch it out, make the angle a little bigger. So an example would be like 120 degrees and, I don't know, 80 degrees. Again, those are just made up to get you to kind of see the numbers. Now that's it for 3.10, the Hinge theorem. So a little trick here, we're actually going to throw 3.11 in to make it feel like there's less videos. Ha. But here we go. So we're not going to do this first part again because we don't have proper tools to make sure. I mean, you can do this if you want. Draw that triangle, and then we'll talk about the sides and the angles and all that good stuff. But that's something maybe for in class to take care of. So let's talk about now triangle inequalities, and how can we tell if we have proper lengths to make a triangle. So here's a couple theorems for you, of course. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So because AB is greater than BC, that means the angle opposite of AB, so that's this angle down here, has to be greater than this angle down here. And again, of course, the side length is going to kind of stretch that angle out, make it a little bit wider. And then, of course, it's going to work in reverse. If one angle is larger than another angle, then the side opposite is going to be longer than the other side. So just to make up numbers again, I'm not pulling these numbers literally out of thin air, but if this angle's 50, let's say that this side is 10, and if this side is 30, it's got to be something smaller than 10. So I don't know, let's just say like 7, for example. The side opposite's going to be shorter because the angle's smaller. So using our new theorems, write an inequality comparing ST and RS. So we just need to write the inequality. So ST right here is opposite of the 29-degree angle, and RS is opposite of the 30-degree angle. So what we could say is ST is actually going to be less than RS because 29 is less than 30. The angle measures of ST, of the angle opposite of ST, is smaller than the angle of opposite of RS. Using it in reverse here really quickly, compare the angle measures. So we want to say angle L and angle N. So angle L is opposite of, so we're talking this angle up here, is opposite of the side that is 6. Angle N is opposite the side that is 5. So we could say that the measure of angle L, I should really use the measure of angle L, is going to be greater than, again, because the side length 6 is greater than 5. Just a little note for you. Okay, so if the side's longer, then the opposite angle is bigger. See how these are opposite of each other, and then how these are opposite of each other. So they kind of are in relation like that. The triangle inequality theorem. So the sum of any two sides of a triangle has to be greater than the length of the third side. So you're going to see a few questions like this where you're given three sides and you're going to be asked, is it possible to form a triangle? So the sum of any two sides has to be greater than the third side. So we could say that generally you take your smallest two and see if it's greater than your largest. So is 4 plus 5 greater than 6? Yes, we could form a triangle. Again, take your smaller two. 2 plus 3, is that greater than 6? No, so we could not form a triangle. Did this wrong. Yeah. Oh, well, I should really do this. It's not less than, so it doesn't work. Or it's not greater than, it's actually less than. So no, we cannot form a triangle. And you could just keep going. I could just keep coming up with various examples. Let's do one more here. So let's say like 10, 11, 18. Could we form a triangle with those three? We'll take your smallest two. 10 plus 11, is that greater than 18? And hopefully you'll tell me that yes it is. So yes, we can form a triangle. Now extension is kind of interesting. But if a triangle has sides as described below, triangle ABC, maybe you should draw it. A, B, C. Side lengths AB is 6, BC is 13. It says write an inequality for the length of AC. So let's just, I don't know, we could go, let's just call it AC. Okay, we'll keep it. So we need to find a low end and a high end. So AC has to be between what two numbers here? Well, take the other two sides. So to find the small side, we'll take 13 minus 6. 13 minus 6 is 7. So it has to be greater than 7. But if I take 13 plus 6, it has to be less than 19. So this side length here has to be somewhere between 7 and 19. And that is it.